A single 100 megabit per second connection can consume 32 gigabytes of server memory in just 20 seconds. I mean, an AI autonomously discovered a novel denial of service attack, and it actively breaks the fundamental web servers you interact with every single day.
Yeah, it's wild.
So today we're taking a deep dive into a stack of recent cybersecurity threat reports from Calif and Microsoft's patch notes to figure out exactly how an AI managed to break the internet's backbone and really what it means for the future of digital defense.
It's basically a textbook thriller, but, playing out in server racks. The target isn't some obscure legacy software. We are talking about NGINX, Apache HTTPD, Microsoft IIS, Envoy, even Cloudflare, Pingora.
Wow, so the biggest ones.
Right. This flaw impacts all of them in their default configuration.
But out of the box, the biggest web servers in the world are just vulnerable. But to what exactly?
Well, it's a vulnerability dubbed the HTTP2 bomb, which exploits something called HPP header compression amplification.
Okay, let's unpack this. HPAC header compression. I know headers are like the metadata of web traffic, right? Like the to and from addresses on an envelope.
Exactly, yeah.
But how does compressing them turn into a bomb? I mean, so instead of a brute force attack, this is like shoving an infinite Russian nesting doll into a doorway and then holding the door open so the building's security can't process anything else.
That is a great way to look at it because, when you compress a file to send it over a network, the receiving server has to unzip it, which takes memory.
Right.
And HPSCK is just a highly efficient way to compress those headers. So the OpenAI codex, in this case, acted as the thief here. It acted completely autonomously and chained two techniques together.
By sending a maliciously crafted tiny package.
Yeah, a tiny compressed package that unpacks into gigabytes of garbage data.
So the server just gets totally overwhelmed.
Right. But the server doesn't just let the lobby fill up, so to speak. It actively tries to process and clear the data, and that's where the second part comes in. Codex chained that header amplification to a slow LoRa-style 0-byte flow control hold.
Wait, slow down there. Slow LoRa is that classic attack that keeps connections open by sending data painfully slowly, right?
You got it.
So why wouldn't the server just drop the connection if the data stops moving?
Well, because Codex mathematically analyzed how these servers manage memory and found a blind spot in the HTTP2P protocol itself. Right before the server tries to clear the memory, Codex sends a network command essentially saying, hey, my receive window is at 0 bytes. I can't accept any data back right now. Please hold.
Oh, wow. So it legally forces the server to pause.
Exactly. The protocol requires the server to respect that command. It weaponized the server's own rulebook against it. The server is stuck keeping all that massively decompressed junk data in its active memory.
Just a tiny trickle of data, legally pausing the connection, and the server exhausts its 32 gigabytes of RAM in 20 seconds. I mean, the fallout from this must have been absolute chaos for system admins.
Oh, total chaos. When researchers at Calif disclosed this, there was just no universal patch available. You had an autonomous, AI-generated vulnerability threatening the entire foundation of the web.
Which directly contributed to the panic we saw in June 2026, right? If I'm looking at the timeline correctly, Microsoft had to rush out like 206 fixes in a single Patch Tuesday release just to stop the bleeding.
Yeah, that record-breaking release included scrambling to address this specific AI-assisted HTTP denial of service vulnerability. CVE 2026-49160 for those tracking.
So what does this all mean? If Microsoft had to deploy over 200 fixes to triage the fallout from this one incident, the traditional way we patch software just feels fundamentally broken now that AI is in the mix.
If we connect this to the bigger picture, we have crossed a terrifying inflection point for global threat intelligence. AI is no longer just a slick tool for vendor keynotes,
Right, it's not just a co-pilot highlighting code errors for human researchers.
Exactly. It is actively and autonomously weaponizing vulnerabilities using non-human logic. You, the listener, are now relying on infrastructure facing threats that humans didn't build.
It's not a human hacker trying to outsmart a human defender anymore. It's a machine mathematically calculating the absolute most efficient way to break a system's logic.
Yeah, human defenders are completely outmatched in speed and scale.
Which leaves you with a final, chilling question to ponder. If an AI can already autonomously chain known flaws to cripple the internet's backbone in 20 seconds, what happens the moment it starts inventing entirely new classes of vulnerabilities that human defenders haven't even conceptualized yet?